Let's look further into the power of for loop. So we already see for loop here. You can start with 1 and finish at 10 and run everything between 1 and 10. But for loops are actually more versatile than this. Let's look at user squares.java. The logic is basically the same as what we see in the squares.java. But the one change is that it will ask user to input an integer as a maximum value. So instead of a number less than a fixed number of 10, now you can change the maximum value. If I change it to 5, it will print from 1 to 5. How high should I go? Let's say 5. Then it will be 1 to 5. Which means the test condition actually can use variable and construct more complex scenarios. So this is the first thing we want to cover. Let me try to print it out. One, test condition can use variable and plural. And also, you can actually use variables in the initialization part. Again, I think we talked about this, that we want to put the initialization here. This is just a side note, but then how about we create a min value? We can get a min value, how low should we want to go? And here, we will set initial number as minimum value, right? How low should I go? Let's say we start at 3, and how high? 5. It will be 3 to 5, right? So the node 2 visualization can use variables too. Okay. And the third is that this update can not only be using ++, right? You are actually using this value to increment number by 1, but you can also increment number by 2 or 3, or any instruction any calculation you can have. But one thing to note, make sure you do change your value, and the way you change that eventually will make the test session false. Otherwise, you will have an infinite loop. Right? Let's run. And I want to starting from 3 to 8. So because I'm increment number by 2, so it will starting with a 3. Then after the first loop, performing the update, the second value of number will be 5. Then after the statement block and update, 5 plus 2 will be 7. So I will execute 7 again. Then I will run number plus equals to 2 again. 7 plus 2 becomes 9. This time, number will be greater than maximum value, which is 8. So we should see 3 rows of output, 3 and 5 and 7. And that's exactly what we are seeing here. Okay. Update can be any expression, but make sure eventually your test section will be false somehow. Okay. And if you notice, we don't only need to increase number session. We can also decrease number session, right? Of course, if you want to decrease number session, you need to pay attention. You need to make sure that the the number after initialization and getting decreased, eventually it will make the test false. So what do you need to do? Right now, if I say it's a minimum is 3, and I keep on decreasing it, 2, 1, 0, it will always be lower than max value. That will cause an infinite loop. That's what I mean by saying make sure eventually your test session will be false, because your update can be any expression, but the calculation result of the expression may not make your test result false. So if we are decreasing the number, apparently we need to make the number high at the lower beginning and low and test the low. Oops. And test to make sure it's greater than the low value eventually. It's a minimum. So we will start by number equals to maximum value and decrease it until the number is not greater than or equal to minimum value. So if we start again by running low value is 3 and the high value is 8, we will start by 8. Minimum, and after execution, it will become 7. 7 is greater than 3, and 6, and 5, and 4, and 3, and 2. Once it's 2, it's no longer greater than 3. So we will exit outside of 4, thus avoiding the infinite loop. Oops, I should. So we have A76543, right? And in fact, this update is more versatile than that. You can even put something that is completely unrelated into this update session, because this update will always be executed after the statement block is done, right? So let's say I'm copying this here and use comma to separate them out. Remember, you can use comma to separate two expressions, and both sides of comma will form one statement, and we are putting this one statement inside of this update session, and we can still run it. 3 and 8, and everything is still the same as the previous output, right? You are basically, there's nothing inside this code block. You don't need to execute anything here, but you will come to this update session and execute this statement. Both this expression, this printout, and the decrement of number. However, while I'm letting you know this flexibility of Java, I need to also warn you that you should not abuse this flexibility. With great power comes with great responsibility. You need to take care of your simplicity, the simplicity of your code. Do not mix normal processing with the loop control structure. Initialization session should only contain initialization code. Update section should only contain update code. And do not mix anything in between. And also, do not place initialization outside. You can do that. I'm telling you right now, you can put initialization outside. And it works. It will work the same way. But do not do that, because it will make your code harder to understand. Similarly, do not put update session inside the code block, as we just discussed. It will make the code difficult to understand. So don't mix processing logic with loop control structure. That initialization be initialization. Let update be update. And let statement block, B statement block.